Hi guys, we have 7 minutes before fire drill, so I'm going to make this as fast as possible. If you need to watch this like multiple times, then have at it. But I'm going to talk really fast, so hopefully you stay with me. Okay, the last thing we talked about in class was that there are 3 big key reasons as to why we have ionic bonds forming. And it's all because of this attraction, but ultimately we have 3 different reasons of energy changes that are creating this ionic bond. So we said that there was ionization energy, there's electron affinity, and then there's lattice energy. So based on just thinking about lattice energy, remember we said that we could calculate lattice energy by taking the constant, multiplied it by the 2 charges, and then divided by the distance, that distance that's separating those 2 charges. Because remember we said the farther the distance, or the more distance that's separating those charges, the less that energy or lattice energy would be. If the charges increase though, we said that was a direct relationship between lattice energy and charge. So if we have a nice big charge, we have a high lattice energy. If there's a lot of distance separating between 2 charges or 2 ions, then we're going to have a smaller lattice energy because that distance is in the denominator. So if we look at this example here, it says without looking at the previous table, so without looking at some calculated values that we have for lattice energy, arrange the ionic compounds, sodium fluoride, cesium iodide, and calcium oxide in order of increasing lattice energy. So you have 3 different compounds here. We know that a higher charge would result in a higher lattice energy. So the first thing that you should look for when you're doing a problem like this is figure out their charges. Well, sodium and fluorine both have 1, so +1, -1. Same thing as cesium iodide, +1, -1. But calcium oxide has a +2, -2. Since their charges are higher, this one must have the most lattice energy. So I know this one has to be the biggest in terms of lattice energy because their charges are higher, meaning then that's a direct relationship with lattice energy. So calcium oxide must be the biggest. But now I need to figure out which one would be the smallest. Is it sodium fluoride or cesium iodide? Well, now if they have the same charges, +1, -1, +1, -1, charge isn't going to be a factor. Instead, I'm going to have to think about it in terms of distance. So I know that as we move down a column, ionic size, ionic radii increases. So as we're moving down and we increase that ionic size, that means the distance is going to increase. So cesium iodide would be really far way down both of the alkali metal and halogen family, and then sodium and fluorine is up more towards the top. So the distance separating sodium and fluorine is going to be much smaller than the distance separating cesium and iodine, right? So what would... Actually, I'll let you decide this. I told you the first one. Tell me which one would be the smallest and then which one... Well, yeah, just tell me which one would be the smallest since I already told you calcium oxide would be the biggest. So you tell me this one, and I also want you to try this one for me. Which substance do you expect to have the greatest lattice energy? Would it be magnesium fluoride, calcium fluoride, or zirconium oxide? Zirconium, well, I'll let you decide that. Okay, let's keep going. So guys, this one is just showing us that if we account for all 3 energy changes, then we can get a good idea of the energetics involved in a process.
We need to go over some procedures as you exit the building for this fire drill.
To be continued.
All students